All right, this is screencast number 3 for Unit 2, Lesson 1, and I'm on page 76. What kinds of patterns can be shown using graphs? All right, some data, such as data about size and mass, are continuous. Continuous data are data that can take on any value. Other types of data can be grouped into categories. For example, data about daily temperature or the number of moons can be separated into categories. Okay, so the first thing we're going to look at is linear relationships. A line graph is a graph that can show patterns in continuous data. On a line graph, the relationship between the independent and dependent variables can sometimes be shown with a straight line. If so, the relationship is called a linear relationship. A straight line shows that the rate of change of the dependent variable with respect to the independent variable is constant. Okay? In other words, y always increases or decreases by the same value in relation to x. So for instance, you have a graph down at the bottom that says density of water at 4 degrees Celsius. Okay? On the x-axis, you have volume, so how much water do you have? And then on the y-axis, you have mass in grams. And if you look very carefully, when the volume is 1 cubic centimeter, go up to the red line, hit it, and then go over, and it's going to hit the y-axis at 1 gram. So the volume is 1 when the mass is 1. The volume is 2, go up to the line, go over and read the y-axis, the mass is 2. Okay? So for each increase in the x-axis, the y-axis increases for this one by the same amount. So it says use the graph to find the mass of 7 cubic centimeters of water. 7 cubic centimeters of water, you go up to the line, to the red line, and then when it hits the red line, you go over horizontally and read what mass that corresponds to. Okay? Look at the data displayed on this graph, formulate an explanation about the relationships among mass, volume, and the density of water. Okay. It doesn't matter what mass and what volume I use on this chart. I am always going to come up with 1 gram per cubic centimeter for the density. Because if I look and I have a mass of 1, then I use the line and I drop down and I've got a volume of 1. If I have a mass of 6, I go over till I hit the red line and then I drop down and that's a volume of 6. 6 divided by 6 is 1. 1 divided by 1 is 1. Okay, so when you take the mass and volume for a particular point, you're always going to come up with 1. Okay, so answer 14 and 15. And then go to page 77 where it talks about frequency distributions. Okay. Oh, before I go on to frequency distributions, I want to say one more thing about a linear relationship. Basically, a linear relationship is kind of like a perfect scatter plot, okay? Remember, a scatter plot, we see a trend, but the points aren't perfect. They're scattered a little bit, and we use a line of best fit. Well, if our line of best fit is actually able to be a dot to dot to dot, then we have a perfect linear relationship, okay? So the two are related, but they're not the same, okay? All right, page 77, frequency distributions. A line plot is a number line that shows the frequency distribution of data. In other words, it shows how often data fall into a certain category. The graph below is a line plot. It's based on the data that's given in the table. The table shows the number of moons associated with different planets in our solar system. 4 planets have 0 to 9 moons. And just for your information, that would be Mercury, which has no moons, Venus, which has no moons, Earth, which only has 1 moon, and Mars, which has 2 moons. Okay? So 4 X's are plotted on the number line above the category 0 to 9. Okay? Each X represents 1 planet. You can see from the line plot that the majority of planets have 0 to 9 moons. Okay? A histogram is a type of bar graph that also shows the frequency of data within categories. Histograms use bars rather than X's to represent data. So a line plot and a histogram are closely related. They kind of show the same thing. Okay. Important. There are no spaces between bars on a histogram. Okay, so what's an easy way to tell if it's a histogram? Okay, if there's no bars, if there's no spaces separating bars. Okay, if there's spaces, it's probably just a regular bar chart. Okay, all right, so I'm going to pause for a minute and I'm going to show you what you should have on page 76 and 77. Okay, so now that I've written on page 76 and 77, and we've gone through this, you can go back and see what I did with the graph, that I used the graph to answer question 14 and question 15. I also went to number 16 and constructed the histogram that went with the table and the line plot that's above it. So make sure that you get that written down and sketched. Also, over by linear relationships, I put a little arrow out to the side and I put that it is similar to a perfect scatter plot. So just keep that in mind. They're not the same thing, but they're similar. All right.